Okay, guys, we're going to do the check your understanding on page 499. And this is going to be the same one I do in class as my sample confidence interval for a population proportion, for estimating the population proportion. Okay, so let's read over it, and I'll bring my paper up. Alcohol abuse has been described by college presidents as the #1 problem on campus, and it is an important cause of death in young adults. How common is it? A survey of 10,904 randomly selected U.S. college students collected information on drinking behavior and alcohol-related problems. The researchers define frequent binge drinking as having 5 or more drinks in a row 3 or more times in the past 2 weeks. According to this definition, 2,486 students in the survey were classified as frequent binge drinkers. First of all, don't do that. Not good for you. Don't do it. Okay, let me read through them, and then we're going to go through each step. So identify the parameter of interest. We got to figure out what we're estimating. We're going to check our conditions for constructing a confidence interval. Then I'm going to show you guys how to find a critical value, which we need to do the calculation. And then we're going to calculate the interval, and then we're going to interpret the interval. So these are the 4 steps of a confidence interval. There's your state, plan, do, and conclude. Okay? All right. So the first thing, let's organize our information. First of all, what's my sample size? Okay? I was told I had a sample of 10,904 U.S. college students. Of those 10,904 college students, 2,486 of those students were classified as binge drinkers. Again, don't do that. Don't be part of that group, okay? So from that sample size and the number of students that responded to the survey for that characteristic, we get to calculate our p-hat, our sample proportion. So we'll do 2486 over the 10,904. So we know our sample proportion, or our p-hat, is 0.228, okay? 3 decimals is fine. Even 2 would be okay. Don't do 1 decimal, okay? Better to do more decimals than not enough, okay? All right, so the first thing said we want to define the parameter of interest. And the parameter of interest is P. What population parameter are we looking for? We're looking for P, the true population proportion of U.S. college students who are classified as frequent binge drinkers. I'm trying to look at my thing here. Let me zoom out a little bit. There we go. Now you can see the whole paper. I will go back and fill in some stuff for the confidence interval process, okay? But I'm going to answer the questions according to the book, okay? Then it said, number 2, to go through our conditions. Well, we know our conditions. Random. It was stated that the students were randomly selected, so that's good, okay? Independence, 10%. Did we have more? Is our population more than 10% of our sample? Well, our sample was 10,904, and if I multiply that by 10, I'm pretty confident there's more than 109,040 U.S. college students, okay? A lot of college students, so that condition's met. Now, our large counts, our normal condition for our large counts, again, we don't have a P, so we have to do n times p hat, and it has to be greater than 10, and then n times 1 minus p hat has to be greater than or equal to 10. So, of course, if I have 10,904 and I multiply it by my sample proportion, it should be roughly the sample. Okay, and I know there's a decimal in there, but whatever. And then 10,904 times 1 minus should be the rest. Okay, so what's that? 8418. Okay, and that is also greater than 10. So all 3 of our conditions have been met. We are good to go. Okay, so now let's construct our confidence interval. First thing we have to do is we have to find the critical Z. Let's recall our confidence interval formula is the point estimate, our sample proportion, plus or minus the critical Z, which we're going to find in a second, times the standard deviation of our sampling distribution. And again, I don't have a P, because that's what I'm trying to estimate, so I'm going to use the P hat, my sample proportion, what I have. And of course, that's my sample size. So how do we find this critical Z? It's the Z-score. Okay, it's a Z-score for the middle 99%. So if I come over here and draw my curve, and this is the middle 99%. I wrote 95 by accident. Together, these are 1%. So each of these is 0.5%, right? So here is my critical Z. So I'm just going to look up in the calculator, do my inverse norm, and find the critical Z for this entire area. So this entire area is 99.5%, so 0.995. Okay, so if we recall how to do that, go to our second vars, or our distribution. There's my inverse norm. So area to the left is 0.995, okay? And there is my critical Z. Let's take all of our critical values, because we're going to have a T in the next section, to 3 decimal places. So this would be 2.576, okay? So my Z is 2.576, okay? So that's how I find my critical Z. And when they ask for work, this is what they're looking for, because they know you're going to run it in the calculator. So how'd you know what to put in the calculator? You thought about this curve. So show what your thinking is, okay? All right, so now I'm just going to fill everything in. I know my p hat, it was 0.228 plus or minus my critical Z over here. And then let's just build our sampling distribution, our standard deviation of our sampling distribution. 0.228 times 1 minus all over my 10,904, okay? So my confidence interval is going to be 0.228 plus or minus. Remember, this whole part right here is the margin of error. So we're going to stick that whole thing in the calculator and get our full margin of error, okay? 2.576, 0.228 times 1 over, okay, hopefully I typed everything in okay. Okay, my point estimate's 3 decimals, so I'm going to take my margin of error to 3 decimals, 0.010, okay? Okay, now let's build the actual interval. So that's my point estimate plus or minus my margin of error, and again, my margin of error comes from my critical value and my standard deviation of my sampling distribution. So if I subtract and I add, so 0.228 minus 0.010, and then plus, there's my interval, okay? So from 0.218 to 0.238. So 0.218 to 0.238. That's my interval, okay? Oops. Then last thing we have to do is interpret this interval. So what does this interval mean? So here's my interpretation. Let me move this up. We're going to interpret this interval. So this simply means my interpretation of the interval is I am how confident, what was this? A 99%? I am 99% confident that the interval 0.218 to 0.238, and they don't need a unit because they're proportions. I'm 99% confident the interval 0.218 to 0.238 captures the true population proportion of all U.S. college students who are classified as frequent binge drinkers. Again, don't do that. That's too high as far as I'm concerned, okay? But that's my conclusion. So if we think about this entire process, it is the state, plan, do, and conclude, okay? I want to go back and embellish a little bit. Okay, so this part right here was my state. I state what I'm trying to estimate. So I'm going to add, I want to estimate, I forgot my T. I want to estimate P, the true population proportion. Okay, these are my conditions. Okay, oh, whoops. I want to estimate P, the true population proportion, whatever I'm looking at a 99% confidence level. Okay, so when I do my state, I always state what I want to estimate. It's either going to be P or mu, which we'll do next, or some other stuff later on. State what you're looking for, and then state the confidence level. I'll tell you right now, sometimes I forget to do that, and I go back and put it in there. Nobody ever knows. Okay, then I do my conditions. So this is my plan part of my confidence interval. Before I go through my conditions, I have to say, what are these the conditions for? These are the conditions for a 1 proportion Z interval, okay? That's the inference method that we're doing. You have to state the inference method. Now, this is the only one we know, and by the time we're finished it, we're going to know about 7 or 8 of these, okay? So this is just the first one. And then we go through our conditions. We did that great. Okay. This is the do part. Okay. I don't think I'm going to change any of that. The do is the do. Okay. And then, of course, at the end when I interpret, this is my conclude. And again, my conclusion has my confidence level, has my interval, and it states what true population parameter I was looking for. Okay? So that is a confidence interval for a population proportion in a nutshell. And this is the same one I did in class, just so you would have a reference to listen back to again. Okay. All right. I'll see you for the next part. Bye.